Ladies and gentlemen, this is Mohammed Awad Sheikh Bashaib, and today I'm gonna represent my engineering project 1, and my project topic is about face mask detection, as you can see, using Java programming language code. My advisor is Professor Dr.Peri GÜNEŞ. So let's start with this presentation. Now, before starting with the presentation, I will show you what I will explain in this presentation. So as you can see under the content section, we're gonna talk about the introduction and the aims and goals of the project and the objective, and I will show you the workflow diagram to make you fully understand on how this program works, and I'm gonna show you the data sets of the pictures of the people with face mask and without, and there will be a little testing and predicted results for you to know how the outcome result will be for kind of programs. So let's start with the introduction. Coronavirus, as we all know, has affected every single individual over the globe. Every individual is taking fundamental measures to decrease its effect. Now, this project here is to prepare a dataset which would detect whether a person on the camera is wearing a face mask or not. And the application, it can be connected to any existing or a new IP mask. Detection cameras also can help to detect people without a mask. Application users can also add faces and phone numbers to send them an alert in case they are not wearing a mask. As we all know, in every project it has its aim and goals. So the aim and goal of this project, as we all know, the coronavirus is spreading rapidly, and the World Health Organization has done everything in order to keep us safe and healthy. So in the support of the ongoing fight against this disease, we are motivated to generate a new insight by providing information about the people who don't wear face masks while using what we love the most, our deep learning techniques and our technologies. What's the objective of this program or of this project? The objective is like a model is created using a dataset with mask and without a mask. This model is created because it will identify people on camera without a mask and send an alert to the respective authorities with the picture of the person without a mask, in order so that to make the people fully understand that this situation is hard, and it will send an alert to the authorities to take the right actions against people who don't take health as a serious matter. Workflow diagram. As you can see in the workflow diagram, it's the diagram of how the program process is taking place. As you can see, this application it has two phases. Phase 1, which will train the face mask detector, and phase 2, which will apply the model and it will send an alert. So let me explain the phase 1 first. Now, as you can see, in phase 1, it will start with the load face mask dataset. Then this will train the face mask classifier using TensorFlow. After the face mask is trained, it will build a model using the dataset. Now the dataset, I will explain more about the dataset later in this presentation, and hopefully you will understand how the dataset works and how it takes place. Now in phase 2, it will start with the build model that was built in phase 1, and the camera will be switched on, or the webcam, and detect faces will be used by OpenCV2. After it, we will extract the face from the webcam video. The face that was captured in the webcam videos will be extracted by using ROI, face ROI. After the face is extracted in the webcam video, we will apply the built model that was built in phase 1 to detect face mask. if face mask is detected, yes, rectangle. If the result is yes, face mask is detected, rectangle round or square round around the face will be shown in green. If face mask is not detected, the image will be captured and it will send to respective authorities with the image of the person who is not wearing a mask. And as you can see, here is the explanation of phase 1 and phase 2. Phase 1, it trains the face mask detector and builds a model. The dataset with and without mask are collected. It will train the face mask classifier using TensorFlow, and it will build the model using the datasets. Phase 2 will apply the model that was built in phase 1 and send an email. It will load the built model that was built. Cameras are switched on and the faces are detected using OpenCV2. It will extract the faces that were detected in the camera video by ROI. It will apply the built model to detect the face mask. If face mask is not found, it captures the image and sends an email with the attachment of the captured image to the respective authorities. Now, now about the dataset part, datasets are collected from Kaggle. Two sets of dataset composed of faces of various people from different parts of the world and of all age groups. One set consists of faces of people with mask, and the other set of dataset consists of faces of people without a mask. How this works and how it looks, let's see in the next slides. So this is an example of a dataset with face mask. So pictures of people with face mask will put in a database in a dataset, and people with no face mask will put on the same dataset, but it will be divided. People who are wearing mask will put under the mask dataset, and people who are not wearing mask will put under the section of no mask. And this dataset will and the model will be built on depending on the dataset of mask and no mask. Testing section. As we said, built models will be loaded using a text.java file. Cameras will be switched on. Faces are detected using OpenCV2. If a person is identified without a face mask, image is captured. Captured image, as we said before, is sent to respective authorities through an email with the attachment of the image of the person who's not wearing a face mask. Now, as you can see below, here is the predicted results of how this application work. Here, as you can see first here, it's a single person without a mask. It's a result of a single person without a mask. The application will look like this if the mask, if a person is identified without a face mask. Now, and here, single person with a mask. The output will look like this. The result will look like this is if a person with a mask is identified. As we said before in phase 1, in phase 2 it will be green if yes, face mask detected. If not, red will be the outcome result. And multiple persons here, one with mask and one without mask. Here are the predicted results of this kind of applications. Conclusion. First we collected the data sets of people with and without face mask from Kaggle, and second we trained the face mask classifier using TensorFlow, and we created a model using the data set, and the built model is loaded. Cameras are switched on. OpenCV2 detect faces, and faces are extracted using the ROI. Then the built model is used to detect the face mask. If the face mask is not identified, it captures the image of the person and sends an email containing the image captured and sends it to the respective authorities. Here, our study concludes that not it only monitors a person who doesn't wear a mask, but also let the authorities know who are not wearing it so that the action can be taken immediately. which is meaningful for the prevention, which in other words, this project or this study helps the prevention of this infection diseases, and it reduces hopefully the coronavirus in public, and hopefully we can go back to our normal lives soon, and meet with our loved ones, and live a happy life again, hopefully. Here is the references from where the datasets were taken, from all the informations. Here all the references. And yes, thank you. This was my time with you. Hope you liked this presentation, and thank you. See you in better days.